Okay, so today's video is going to be on how to track an object in Kinovea and export that data into an Excel spreadsheet. So I'm going to open Kinovea here, and I already have a video saved. So what you first want to do before you even start recording, you'll see here I have on this little blue dot on my ear, and that's to create contrast against my skin so that it's easier for Kinovea to track it. So now once you're in the video, the first thing you're going to want to do is create like a line of reference. Here I've put this ruler up on the screen, so I'm going to go as much as I can on the ruler. So there is 13 where the little hand is, 13 centimeters, and here is 44 centimeters. So what I'm going to do is I'm going to draw a line from 44 centimeters all the way up to 13 centimeters, okay? Now see, I've already done this since this is a pretty recent one that I've been working on, but it's already given me the length. So if you want to do it, just right click on it, press calibrate, and then specify the length and make sure it says aligned with image axis. On the newer version of Kinovea, this is a must. I don't know about the very old version. I saw that in an article recently. So now press apply, and now during your, actually I think I'll make this completely visible. So now what you're going to want to do is get the pointer or marker and find the point you want to track. So for me, that's going to be right on the black dot on the blue tape right here. And you select the point, and you press escape. And now that's going to be tracking, or it's not going to be tracking yet. So those are the coordinates of that point in relative to the picture. I'm not really sure what the values stand for, but all I know is that the Y value is the second value right here. So right click on it, go to tracking, and press start tracking. So now when I play it, it's going to be tracking my head position when I'm walking. So now if I want to bring that into an Excel, all I have to do, pause it, file, export to spreadsheet, new plot. Oh, sorry, it's not marking with the point because the point is just going to find one data point, and that's going to be the point all the time. So you don't actually need this point for any tracking, but I like to have it there for reference. So now what you're going to want to do is right click somewhere on top of the point, and now tracking, oh sorry, it selected the point, not directly on top of the point. Right click, track path. There's going to be a little plus mark in the middle of that box. Try to put that right on top of the point, okay? See, we're at the beginning of the video. Now let's press play, watch the whole video play through. You'll see it's tracking the little trails of where where that point is moving when I'm walking. So now that it's over, I can just pause and go to File, Export to Spreadsheet. I don't really know why it's called GNU plot, but make sure it's a .txt file. Don't choose the Microsoft Excel. I don't know why it doesn't work properly. Just choose the new plot. And now you save it here. I'm going to do this test run. Okay. So now we're going to go into Excel. And now here you're going to go to data, whatever you want to call it, from text CSV. That means it's going to be taken from a text file. CSV stands for comma separated values, except this one is going to be space separated values. So now data, and here I have test run, 7:09 p.m., 7:09 p.m. You guys can't see that on this. So test run. And what Excel's going to want to do is going to want to see how can we help you with this data. So you're going to want to press transform data, not load. What you're going to notice here is that every single value has a space between it, and up at the top, every single value has a space in it. So what you're going to do is split columns, and then by delimiter. Delimiter splits the value based on a specific thing, and in this place we want to split it based on the space. So now each occurrence that it splits every single one, split it, and I'll create an extra column here. We don't need that, but we can delete that once we get in. You'll see we'll have T, which is time, X, which is the points on the x-axis, and Y, which is the point on the y-axis. For my project specifically, I'm going to be using the point on the y-axis. So let's press close and load. And now we'll load the data in here. So we have 267 rows. So let's write that down because you don't want to scroll all the way down. Now, unfortunately, it's going to keep that as part of that, so we don't really need to worry. Let's delete this extra column here. And now we have this extra column here saying 267 rows. So all we're going to need is T and Y. I would delete X, but it might not hurt to have it. So let's copy the column and paste it into G. And let's copy C and let's paste it over here. See, now we have time and we have Y. But you see there's this little error warning on each of these, and that's because these aren't in numerical format. These are just in like a normal format. So what you're going to do is painstakingly highlight every single value. Now there probably is an Excel function to do this. I don't really feel like finding it or writing it in VBA. What you want to do is convert to number. Now after you convert it into number, don't click anything because you don't want to get rid of the highlight. Go to Insert, choose a graph, scatter plot, and would you believe it, we have a graph of oscillations. That's because when someone bobs their head when walking, it creates an oscillation. So now we can attach these with an outline in between the line. I don't really care what color, but I would like it to match the points. And let's clean up the axes a little. So the bottom axis, the maximum amount of time we have looks like it doesn't peak before more than 11.8, I'd say. Okay, a little bit of an overestimate, 11.5. Okay, and the minimum, it doesn't happen until around 2, I'd say. Yeah, sorry, the minimum's right there for time. For the Y, it looks like it's already cleaned up our Y-axis nicely. So we can label this now with axis titles. This is going to be time. This is going to be point position on Y-axis. And now what I did was I'm attempting to determine head stability, and a way I decided that was to find the head stability at the point before I start walking and find the average of differences for each data point separate from that. So let's go back in here and let's go to the beginning of when I'm walking. This is why I had the tracker enabled. You're going to see Y here, 28.95. So let's go back into Excel, equals 28.95 minus, and our Y-axis is on H6. H6 and we remember we said we had 267 rows, so 6 plus 267 is 270, H273. So now this is going to create a very long column. I should have probably actually done this near the top, so I'll do this here. Average difference. So now equals, what was the value? Sorry about that, guys. It was 28.95 equals 28.95 minus H6 to H273. So now what this is going to create is a very long column of the differences from the height at the very beginning to 27.95. And the way this works is, so it's better if I draw it. I'm going to open MS Paint. So when you're running, you want to keep your head stabilized. So you can imagine this one point as a stabilized point. And if we draw that over time, it's going to be like this. Flat. This is as flat as I can make it. However, since we're walking, we're going to have oscillations. This is the point moving around in real life. A good runner has little oscillations, but a bad runner has big oscillations. So this is basically a dumbed down version of trying to find out numerically the oscillations and how rough they are. So I'm going to do equals average, and then K1 to K267, because it went to row 267. So I was going to give us the average differences, and what do you know? 0.218. And there you have it.